good day. My name is RJ Bugna from Team PGH, the best thesis ever. We're here to report about repeated measures ANOVA. Ano ba yung repeated measures ANOVA? Ito ay kinakalooban ng one factor with at least two levels of dependence. Ulitin ko, one factor with at least two levels of dependence. By saying that, the levels are dependent, di ba? Kasi nga, they are dependent kasi pwede silang magkatugma-tugma in some way. Pero, hindi pa yun ang sasabihin ko. So, it means that they shared variability in some way. Meron silang pagkakatulad in some way. Ganon yun. Okay? Then, the repeated measures ANOVA is almost identical to one-way ANOVA. Yung one-way ANOVA, mapapaliwanag yan mamaya. May exception yon, yung pagkakapareho ng repeated tsaka ng one-way ANOVA. Except for one additional calculation we must perform to account for this shared variability. Ulitin ko, yung exception is for one additional calculation we must perform to account for this shared variability. Okay? So, yun muna. Okay, I'm back. I'm RJ ulit from Team PGH. The best thesis ever. Ayan. Nandito ulit ako para i-report is what is repeated measures ANOVA. Ano ba siya ulit? Siya yung one factor with at least two levels that are dependent. Okay, paano ba siya mapapaliwanag in table? Makikita natin yan. Kunwari, it's me. 'Di ba? Gagawa ako ng table, pero tatlong table lang gagawin ko. Paano ba 'yon? O sige, iti-test ko muna siya. Kunwari sa anti-anxiety medication. Ito, mini-measure niya, they measure the anxiety of 7, measure namin pala yung 7 anxiety participants ng 3 times. 3 times namin silang mineasure yung anxiety nila. O, once before taking the medication, then once on 1 week, ayun, pangalawa na yung 1 week. Then, taking after the medication, 1 or 2 weeks yung pangalawa. So, meron tayong baseline, baseline, then week 1, tapos meron tayong week 2. Kaya, tatlong tables ang gagawin natin for taking the anxiety medication, di ba? Anxiety is rated on a scale of 1 to 10. 10 being the high anxiety and 1 being the low anxiety. Are there any difference between the three conditions using alpha? Ano ba yung alpha? Ayun yung variables. Significant variables. Okay na yun. Ayos ba? Okay. Ayan yung table na pinapakita, ay ini-explain ko kanina. So, nakikita nyo, before, tapos yung week 1, tapos yung week 2 ng mga anxiety taking medications patient. Ayan. Nakikita nyo? So, go. Okay, I'm back from the dead. Hindi, joke lang. Okay, nandito ulit tayo para i-report sa inyo kung ano ba ulit ang repeated measures ANOVA. Naintindihan niyo naman yung mga sinabi ko kanina. So, marami akong sinabi kanina. Kung nakikinig kayo, sana naintindihan nyo. Meron tong, yung repeated measures ANOVA, meron siyang iba't iba or different steps. First step is define null and alternative hypothesis. Okay? Define null and alternative hypothesis. The second is state alpha. State alpha. Nulit ko, state alpha. The third is calculate degree of freedom. Ewan ko, hindi ko maintindihan tong calculate degree of freedom na to. Pero, I'm free. Ayun lang yun. Okay? 4, state decision rule. State decision rule pala. Rule, sorry. Hindi role. Rule. Okay? Then, 5, calculate test statistics. Calculate test statistics. 6, state rules. State results. State results. State results. Then 7 is state conclusion. Last is state conclusion yon. Okay?
Good morning everyone. My name is Neil Patrick Milan from PGH. And ang aming report sa inyo is ang repeated measures of ANOVA. Bale, what do you think from repeated measures of ANOVA? Or what do you mean by repeated measures of ANOVA? Bali, gaya nga nung na-discuss ko RJ, it is the equivalent of the one-way ANOVA but for the related, not independent groups, and is the extension of the dependent t-tests. A repeated ANOVA measures. ANOVA is also referred to as within subject ANOVA or ANOVA correlated samples. 'Di ba? Napakalinaw. Ngayon, magbibigay ako sa inyo ng example table para mas lalo nyong maintindihan kung ano ang ibig sabihin ng repeated measures ANOVA. Bali ganito kasi yan.
So here's our example. We've got 8 subjects and we're looking at the effect of a drug on clotting time, on how long it takes for a subject's blood to clot over time. So they get a pre-treatment, a value after 2 weeks and after 4 weeks. So the null hypothesis is that the means at each time, so pre-treatment, 2 weeks and 4 weeks, will all be the same for the patients. And the alternate is that at least 2 of the means are statistically significant from one another, assuming a significance of 0.05. And so just to continue, we've added one column over here, which is just the treatment means over time. And so what that is basically is this 5.333 is just the means of 8, 7, and 1. And similarly, this value 3 is just the means of 5, 3, and 1, just so you have a lay of the land. So our grand mean is 5.5 minutes, and again, remember that the grand mean is the mean of all 24 of these measurements right here. Okay, and I'll leave it to you to calculate that it's 5.5 minutes. And the sum of squares subject is A, which in this case is 3 because there's pre-treatment, 2 weeks and 4 weeks, there's 3 groups. And it's, let me change my color again, and it's times the value of 5.33 minus the grand mean of 5.5 squared plus 5.33 minus the grand mean of 5.5 squared, so on and so forth till you get all the way down to the 8th subject. When you sum all that together, you get a value of 62. And your degrees of freedom associated with that are the number of subjects minus 1, 8 minus 1, which is 7. So, from the previous lecture, you should be able to calculate these values here based upon the equations that were given. But if you, going forward, you can put the sum of squares subject, we've now found it to be 62, with a degrees of freedom of 7. We can find SSE by subtracting 62 from 111.25, and we get 49.25. And similarly, with the degrees of freedom, we can subtract 7 from 21 and find that has 14 degrees of freedom. So now we can calculate our F statistic, which is the MSB divided by the MSE. So the numerator is just 82.75 divided by 2. The denominator is now not 111.25 divided by 21 like it would be in a one-way ANOVA, regular one-way ANOVA, but instead it's this subset with this 49.25 divided by 14. So when you do this, you get the F statistic being 11.76. And so it's important to note that removing the subject variability from the error term can in some cases reduce the denominator depending on your degrees of freedom and make the F statistic larger and actually more powerful and able to detect even smaller differences than with a...
Yan, going back sa akin, ako po ulit si Neil. Ngayon, explain ko po sa inyo yung repeated measures ANOVA example. For example, meron po tayo na anticoagulant drugs. Tinetest natin yung time, yung clotting time niya, kung gano'n siya ka-effective. In using repeated measures ANOVA, we will try, for example, we will try to get 8 subjects, and sa pre-treatment, kakuha tayo ng pre-treatment, after that is after 2 weeks, then after 2 weeks again, or after 4 weeks, then we will get the treatment mean over time. For example, gaya ng pinapakita natin sa table na meron tayong 8 subjects, di ba? do sa 8 subjects, meron tayong, for example, sa pre-treatment time is we got a clothing time of 8, and after 2 weeks we get a clothing time of 7 minutes. Then after that, after 4 weeks is we're gonna get a clothing time of 1. Then after that, we're gonna get all of them, the 8, the 7, and the 1, and divide it by 3 so that we could get the treatment mean over time, which would result to 5.33. And we will do that through all the subjects, which is 8 subjects. We're gonna do that all over and over again. Then after that is we're gonna get the treatment mean over time. Yung treatment mean over time, gaano kahalaga yon? Kasi pag nakuha natin yon, makukuha natin yung grand mean, which is the most important sa ating repeated measures of ANOVA. Para ginagamit ito sa pagkuha ng SSE or yung summation of squared errors. Bali, yun yung mahalaga sa paggamit ng repeated measures of ANOVA. Yun lang po at salamat. Peace.
Good morning o good evening guys. Ako nga pala si Neil Pichay from PGH. Yung susunod na ipapakita ko sa inyo is isang tutorial para sa SPSS. Isang program siya para mapadali ang buhay nyo gawin ng mga statistical data para sa thesis. Bali, ito yun.
In this video, I'm going to use SPSS to perform a repeated measures ANOVA, also known as a within subjects ANOVA. So here on the left we have our prompt. Let's perform a repeated measures ANOVA. Researchers want to test a new anti-anxiety medication. They measure the anxiety of 7 participants 3 times. Once before taking the medication, once 1 week after taking the medication, and once 2 weeks after taking the medication. Anxiety is rated on a scale of 1 to 10, with 10 being high and 1 being low. Are there any differences between the 3 conditions using alpha 0.05? And down here we have our data. So, let's use SPSS to perform this ANOVA. Right now we are in data view, and we have no data entered. First, we need to go into variable view, down here, to tell SPSS what variables we have. Well, here our variable is basically time. We've got before, week 1 and week 2. And our dependent variable is anxiety. So here is how we're going to set this up. We're actually going to put in before. We'll put in week 1. Oops. Can't put that in there, obviously. We'll put in week 1. And we're going to put in week 2. So there we go. We can leave all of this information the same for now. Now we're going to go back here. Now the reason we set it up this way is because, remember, we're measuring the same 7 subjects 3 times. In SPSS, every row refers to a different subject, so we're going to fill out 7 rows. So here, for the before condition, we're going to put 9, 8, 7, 8, 8, 9, 8. For the week 1 condition, we've got 7, 6, 6, 7, 8, 7, 6. And for week 2, we've got 4, 3, 2, 3, 4, 3, 2. So there we go. It actually looks just like the table we have over here. Now that we have this in here, we're going to go to Analyze. And then let's go down to General Linear Model. And finally, click on Repeated Measures. Here, we have a factor with 3 levels. We're going to call this factor time, and then we're going to add it. And now let's hit define. We're going to take these 3 values before week 1 and week 2 and hit this arrow over here. So now SPSS knows that this within subjects variable is made up of time, week 1, and week 2. We're not going to worry about these options and stuff for now. We're just going to perform the repeated measures ANOVA. So let's go down here and hit OK. Here we have our repeated measures ANOVA. We entered in the variables before, week 1, and week 2. multivariate test is not something we're going to worry about right now. We're not going to worry about Mauchly's test of sphericity either. Here, we want to go down to tests of within subjects effects. Our variable that we're looking at is time, and we're going to look at sphericity assumed. All this other stuff is, for more advanced topics. Here, we look at time, sphericity assumed. We have our f value and our significance level. Here, our f value is 222.00, and our significance is 0.00000 something very, very close to 0, but not exactly 0. Now, because our significance level, our p-value, is less than 0.05, we can reject the null hypothesis and say that there's a difference between these three groups. In this example, what we're saying is that we think, because we rejected the null and said that they're different, we think that the medication, the time after taking the medication, is having an effect on high anxiety. And now we've done a repeated measures ANOVA using SPSS.
Guys, thank you for watching our video. Para kay Neil Milan, tsaka si Kuya RJ. Maraming salamat sa panonood. Ako nga pala ulit si Neil Pichay from PGH, Team Pogi, Guapo, Handsome. Saying goodbye and thank you.